Okay, so a quick solution about this made-up problem quickly is if I have a static scenario, there's 12 kilograms held over there, 24 kilograms over here. What is the tension that the rope needs to support? Well, if it's asking for the tension of the rope, you might want to draw, the first thing that comes to mind is maybe draw a free body diagram of the rope because you are asking about the rope, right? So that's the rope, right? We'll draw the center of mass over there. What is in contact? Well, it's contact from here. This guy is the 12 kilogram holding up the rope, or is it pushing the rope down? I think it's holding up the rope, right? It's connected. So this contact point is holding up. So we have the force on, let's call that the tension. The tension on the rope by A. What's A? If I write this in an exam, the TA would go like, what's A? Well, you need to tell me what's A, right? Because if you call this A, this B, that would be the wrong direction. So whether this is right or wrong depends on what you label things. So another thing we learn in physics, just a soft skill in general, not necessarily a hard skill of equations and stuff, a soft skill in general, general scientific thinking and physics thinking is be precise and also make sure your language is precise, which means label what variable you're talking about. Don't be vague. When you talk about directions, make sure you give precise information. When you write something in your steps, make sure that it reflects what people can actually match up and tell what you're saying. And this contact point of the rope, right? That's another contact point, is that it will create a tension on the rope by B, right? So B is going to create a tension that's dragging the rope down, okay? So it's inextensible, again, massless. The fact that it's massless, right? If I'm asking for the tension of the rope, you might ask, well, the tension on the rope is, do you mean by A or by B, right? It's a valid question. However, if it's massless, then this is, right? Just with a quick recap, this is Newton's by second law, right? You put rope, rope, rope. In this case, the rope is massless. It's also not accelerating because it's static. But usually it's really this that tells you the left-hand side is 0. So I'm gonna call downwards positive this time, just for the sake of it. You know what? Let's make it positive y upwards. It's just to show you either way works. So the net force is going to be T on. Yeah, I'm going to be a little bit lazy. I'm going to call that T and T prime. So again, notice I introduced a new variable. I've labeled it in the diagram. Now I can use it in my equation. So T minus T prime. So what does that imply? Because this side is 0. Yeah, I have enough zeros there. So T equals to T prime. So these are the same, okay? But that does not tell me what the value is. It just tells me the tension on both sides is the same. So now, well, maybe let's investigate the free body diagram of this guy, right? Because this guy has a weight that's probably going to contribute to the tension. So we'll draw the free body diagram of B. Did I label B? Yes, I did. Good. So the free body diagram of B is there's a tension on B by rope, and there is the weight, because that's the only contact force. The other non-contact force is the weight on B by Earth, right? It's gravity, right? So we notice this is rope on tension on rope by B, tension on B by rope. This is Newton's third law, so this is the same as this. So it's the same as T prime, but by second law, this is also the same as T. Okay, so different things going on, but that's okay. Yeah, and now we're going to do the very repetitive thing. Now you see the pattern starts to arise. The more you do this, this is the mass of, not mass of rope. I'm analyzing B, so I better put this over here. What can I say? I can say, well, this is 20. Let's see. Let's plug in variables before I plug in numbers, right? So remember all the steps I wrote down. The net force on B. What did I say? I say this is positive. All right. So I'll have T. These are all the same, so I'll just use the simplest one. Minus W. Okay. Technically, I should call that W before I use W, but I think that is clear enough. Sometimes I'll take a little bit of liberty. If you want to be absolutely precise with your solutions, do that even better. Okay. Yeah, so now this guy is not accelerating. Let's see, we can plug in numbers now. Yeah. So what do we know? Well, we know this is 24. This is 0 because it's not accelerating, because I said it's static. Then T minus W is mg, so we can put in this. Let me temporarily use 10 for just simplicity. Right. Then we can decide it's going to be 0. So I can solve T is 240. I'll put in the units at the end, newtons, right? And if I use 10, if you use 9.8, put that in the calculator, you can get it. So I need a rope that can, if I have 20 kilograms over here, I need a rope that can support 240 newtons amount of tension or force.